Good afternoon, students. Today we're going to be looking at working through an unplugged activity, so not on your computers, but actually with a deck of cards is what you're going to need. And we're going to look at processing and how computers go through processing information and the inputs and the outputs, and then the algorithms or the steps that they go through in order to solve problems. And I know it's a challenge right now not being able to be at school. So what I need you to do for this activity is to find somebody else in your household that can participate with you. Might be a sibling, might be a cousin, might be the next door neighbor, but somebody who you can work through some of this process with in order to have the feedback that you're going to need as we go through this. Now, the first activity I want you to do is to take 10 playing cards out of the deck. I would ask that you leave out the face cards, the king, the queen, and the jack, unless you understand where they fall in the process, in the order. If you don't, the way most games are played, you start with the 1, you count to the 2 to 3, 4, 5, 6, 7, 8, 9, 10, then the jack, then the queen, and then the king. So I want you to pull 10 cards, leave out the face cards, the jack, the queen, and the king, and set those cards in front of you. So I have my 10 cards here, and our goal for this activity is to put these cards in order, flipping over one at a time, and getting them from the lowest on the left to the highest on the right. Now, if you've got your partner there working with you, the goal here is to not say anything, but just to work through the process. So as I flip my cards, I'm going to start off, and my first card is a 7. This is a little hard to do with this screen. My first card's a 7. Knowing where a 7 falls in the range, I'm going to be near the higher end in my 1 through 10. My next card is a 9. I'm going to put that to the right of the 7. As we count up, the 9 will come after the 7. Take my next card, a 6. I'm going to put that right before the 7, knowing that 6 comes before 7, and so on. And I want you to work through this once, just trying to make sure you get the numbers in the right order. Now, if you have duplicate numbers in your deck, that is okay. Just make sure that if you have 2 3s, that they are right next to each other. Doesn't matter which suit is first, but just that those 2 cards are right next to each other in the order. So I'm going to give you a couple, about 30 seconds to try this out. Put all of these cards in order to see get the feel for how it works. So how long did that take you to put your cards in order? You know, I have 1 through 10, the ace being the lowest, the 10 being the highest. I was able to put my cards in order fairly quickly. How about you? Can you go faster? You know, I didn't set a time limit on this to begin with. I didn't set any expectations. I just wanted them in order from the lowest to the highest. So now what I want you to do is shuffle those cards up, mix them up again. And now I want you to take those same cards, and I want you to turn them one at a time and place them in order as fast as you can. Ready, set, go. Now, I know a lot of you can count 1 to 10, and I know that you are very quick in doing so. So congratulations. Now, I want to talk a little bit about some of our vocabulary that we're going to be covering in this section. And the first off is the inputs. What is an input? Well, in our case here, our input is our random deck of cards, our random cards that we have to take and we have to sort. Our output is our sorted deck going from 1 to 9. And the process that we're looking at is how we go through those steps, how we go from a random 10 cards in a random order down to 10 cards in numerical order, counting from 1 to 10. So the process, the steps that we create to go through that, to create that, That's our process as we move forward. So what is the process that you went through in order to put the cards in order? Did you look at one card like I did to begin with? Okay, here's the 8. The 8 is near the end. I'm going to put it more to the right. And then you take the next card as a 4. 4 is less than 8. So I'm going to put it to the left of the 8. The next card is my 9. I'm going to put the 9 just to the right of the 8 as I count it up. Is that the process that you went through? That's the one that I went through when I started working on this. And that leads us into the definition of an algorithm. An algorithm is a precise set of steps, the precise sequence of the instructions of the steps that we went through in order to take our inputs, our random cards, and turn it into what our desired output, which was our cards in order from 1 to 10. So now my question that I want you to ponder really quick is, how can this activity that we just did, how could a computer do it better than we did? Now, before we answer that question, I have another activity that I want you to do. And this is where you need your partner for the most part. I want you to pull out 5 random cards. I've got 5 random cards here. I'm showing them to you. I'm not going to look at them. And in this case, this is where you need your partner. What I want you to do is lay out your 5 random cards in order. I'm going to shoot my screen down so you can see it maybe. So I've got my 5 random cards laid out in order, just next to each other. The back's up so I can't see which card it is. And with your partner, I want you to hold up 2 cards, and your partner is going to point to the bigger of the 2 cards. Now, there's no communication allowed during this activity. You're going to be completely silent. So your partner, you're going to hold up 2 cards. Your partner is going to point to the bigger of the 2 cards, and you're going to work at putting the cards in numerical order from the smallest to the largest, but you don't get to look at the cards at all. So I'm going to start this, and this is going to be a little weird because I'm going to do it with the camera, which means I can see it. So I guess I'm kind of cheating. And then I want you to do it. So if I picked up 2 cards and I looked at them and I said, okay, point to which one is larger, you're going to point to, oops, wrong hand, this one. And so I know that that card is larger, so then I'm going to switch the cards, knowing that this one is larger, this one is smaller. I'm going to put this one down first and put this one second. And then I'm going to pick up 2 more cards, and I'm going to determine which one is larger and which one is smaller, and I'm going to adjust them one way or the other in order to make it so that my 5 cards that I've chosen end up in numerical order. And if this shows up backwards on the computer, I am sorry. This is the joy of a camera. I'm going to make them show up in order. As you can see, my smallest over here being a 1 to a 3, 4, 8, and then up to a 10. So now it's your turn. Now, if we were in the classroom, this would be where I would have you take your steps and go find another partner to work with and work through your steps with that partner. But in this case, I want you to think about it and think about the steps that you did. Did it work for you? Were you successful in putting the cards in the correct order? Did you find a better way to do it as you worked through than what you originally thought? Now, I worked through this problem with my sons, with 2 of my sons, and they were able to grasp it fairly quickly. Okay, if I hold up these 2 and I shuffle them around and I work through it, I can come up with the right number of steps. How about you? How many steps did it take for you to get those 5 cards in order? Now, using your steps, I want you to, instead of 5 cards, I want you to grab 10 cards. Oops. And try and make it work with your 10 cards in a row. And see if you use the same steps to go through it as you did with the 5 cards. Did you use the same steps as with 10 cards? Give it a shot right now, and then you can let me know how you did. Okay, students, was your process any different from when you used the 5 cards or when you used 10 cards? Did you follow the same steps? Now, I'm going to assume that it took you more steps with 10 cards than it did with 5 cards. But if you had built your process, which is an algorithm, if you built your algorithm correctly, you should be able to use the same algorithm each time as you worked through this. So, if I were to take my 5 cards, and the way I came up with my personal algorithm, if I hold 2 cards up and you tell me which one's the highest and which one's the lowest, if this one is the highest, then I'm going to move this one to the side and move this one to the right. Now I'm going to pick up that one and the next one, and you tell me which one is the highest. Okay, so this one is the larger one, so this one goes down first. I'm going to set this one to the right of that. Now I'm going to pick up 2 more cards, and I've got a 4 and a 10. Which one is the highest? You point to this one as the 10. I know the 4 needs to go down first, and then I'm going to put the 10 down. And then I'm going to pick up the 10 in the last card I have, which is an 8. And you tell me that this is the highest card, which means I need to put this one down next in the order, with this one being last. And when I do that, I have all of my cards in an order. Now, I know this is a lot of steps to go through for 5 cards. And I hear that a lot from my students in the past. Why am I going through writing an algorithm, writing a process in order to sort 5 cards when I can easily do that very quickly? And you're right. It probably takes more time to write the algorithm to make sure the steps are correct if you're only sorting 5 cards. But how about if you're sorting 10 cards? How about if you're sorting 15 cards? How about if you're sorting 52 cards? Or we could keep going. How about if we're sorting data that is in the neighborhood of 1 million data points and trying to figure out the order? You don't want to do all of that by hand now, do you? So that's how we would find that using a process, writing a program to solve that for us, makes the most sense. We practice in small groups so we can understand how it comes together. But if we write the program well, the algorithm well, we can take that and we can use it for huge amounts of data. Not just 5 cards, not just 10 cards, but how about 10 decks? How about 100 decks of 52 cards each? Now, you wouldn't want to do all that by hand, would you? When a computer could solve all of that for you. Now, as we're doing this online and not face-to-face, what I would like you to do is, using Canvas, I want you to type out your steps, how you're taking your inputs, your random deck of cards, and you're creating the output, the ordered deck of cards, however many you're using. I want you to give me the steps that you use in your process so that I can take a look at it and see how it works. And I want to try it out. I want to make sure that you got all the steps that you need and that I can use your steps in order to take a deck of cards or 10 cards or a handful of cards and make it work. Running out of time here for our lesson today. Hope you all have a great day, and I look forward to talking with you later. Take care. Bye.